the updated wetlands, we want to reapply this formula to this area so we can see what's changed over time, how much of habitat have we lost over time for breeding waterfowl. Another study we're working on right now is a spring migration study. For waterfowl, the ducks winter down south and then they come up north to breed. One thing that we think is a real limiting factor for the waterfowl is when they're traveling north in the spring, so there's not enough habitat for them to feed as they go up. So they're not making it to the breeding grounds fat enough or healthy enough to actually breed, which reduces the population. So right now we have a study ongoing with the Ohio State University and Southern Illinois University to, we have 6 study sites, graduate students there working on trying to find these different habitat parameters that the waterfowl are using and how much food is available for them, different type of wetland habitats. And again, we're going to use that information to apply it statewide using this new wetlands inventory. The idea here is that if you look at the blue line, which is the supply, this is how much food is available, and then the red line is the number of breeding waterfowl. At some point, and this is the time, so February, March, April, May, June, July, August. So sometime during the year, the numbers of birds and the supply are going to intersect. So basically, after about the middle of March, there's no longer enough food available for those waterfowl to feed on, and so they're going to have to go somewhere else or make it, or be hungry when they get to the breeding grounds. So this is kind of information that we're using the updated wetlands for to order to apply our breeding mallards and also our supply and demand kind of curves. Is there enough food out there available for the waterfowl? So in the end, that's kind of the big picture. That's what we're going to be using it for. This has lots of other applications as well. The state of Michigan is doing a wetlands functional assessment. And basically, each wetland can be broken down into function. What is it good for? Some wetlands are really good for surface water retention. Some are good for stream flow maintenance. Some are good for nutrient transformation. Some are good for wildlife, shellfish, fish habitat, and so forth. And so what they've done is they've taken the pre-settlement wetlands, how much was available, and then basically how much is available now, and then what's the capacity left. So as far as surface water detention for this particular county, this particular watershed, only 53% of the surface water detention capacity is left from the original pre-settlement data.
Pre-settlement, you mean pre-European?
Yes.
Okay.
Yep. 1850s, something like that.
Okay.
This time frame for that. And so getting this updated information for wetlands also allows us to go back and look at what was originally there, what's there now, what we lost as far as function goes, and help those watershed groups to target restoration efforts to target some of these functions as well. And then also we can create maps like this where all these red areas are wetlands that used to be there in the original inventory back in the late 80s. They're no longer there, they're being farmed. And so these are primaries for us, for Ducks Unlimited and other groups to go out and work with those farmers to try and convert those back into wetland restoration projects.
How do you know they're wetlands?
Those were originally identified based on photos from the Fish and Wildlife Service on that original inventory. They, when they were looking at the photos, they could see a wetland there, so identified those as a wetland. And now when we look at the photos, we can tell that it's actually an actively farmed field.
And that original survey was in the 30s or the 80s?
80s. 80s, yeah. So what do we want to know in this current inventory of wetlands? Obviously we want to know what's there now so that we can do all these modeling exercises and figure out what's available. But the other thing we want to do is track the changes over time. What has changed over time and why has it changed? And we're kind of tracking 3 different things. As far as a conversion, was it converted due to agriculture? Was it converted due to development? Was it converted due to like a recreation or other activity? That's actually a golf course. So the importance of this, kind of knowing why it's changed, is if it's been changed due to agriculture, this is a prime area for us to go and try and restore. If it's changed due to development, we're probably not going to go restore that because it's already been converted to development, and the likelihood of that happening is pretty small since it's already been developed for housing and other activities. So that's one of the big things in our kind of conservation planning activities, is to figure out which wetlands have been converted and then also which ones we can potentially go back and restore. As far as the update process goes, Basically what we're doing is we're on our computer screen, we have the imagery in the background, and then we have the wetlands identified up here from the original inventory from the 1980s. And then basically what we do is we look at it section by section, we look at each wetland, identify if it's still there, and then if it's not there, then we identify why it's not there, if it was due to agricultural development and so forth. If it's still there, we leave it alone. If it's changed class, if it was labeled as like a shrub scrub, and now we can actually tell if there's big trees there, we'll change the class from a shrub scrub to a forested wetland, and so forth. After we're done with this section, we'll move on to the next section, same thing. And then when we're done that section, we move on to the next section. Basically go section by section throughout the whole county. And then once the county's done, we do some quality assurance and checks to make sure everything looks good. Then we move on to the next county. So it's kind of a rather meticulous process. We currently have six people doing this right now in our office, doing the updates for the state. As I said before, why it's important to have kind of different images. In the spring, southern infrared image up here, you can see that there's dark areas. These areas here are full of water. So we can label those as wetlands and most likely open water. But also when you look at the summer image, you can see that in the summer image, these areas are full of vegetation here. But this is still dark, this is open water. So it's important for us to know kind of the differences, because this wetland here will get classed differently than this one here. This is full of vegetation, will be emergent wetland versus an open water wetland. So using multiple dates imagery and different types of imagery helps us kind of identify if the wetland's there, and then also the type of wetland that we have as far as the class goes. Is it emergent, is it open water, is it shrub, scrub, so forth.
Have you had any problems over the years? I mean, as they're doing these other states going on doing their surveys, you had any really dry years where you go out to find wetlands and it's kind of hard to even find them when it's kind of been a drought that year?
Yeah, that's kind of one of the difficulties in mapping wetlands, is the wetlands change over time. And depending on which year you identify them, it could be a really wet year, so everything looks like a wetland, and then the next year could be really dry, so nothing looks like a wetland. And so we've had some difficulty, and that's another reason why we use multiple dates and imagery to try and figure out, trying to get rid of some of those differences just because one year is really wet and 1 year is really dry, so we can actually tell what the boundary is of those wetlands. So it is difficult as far as figuring out the wetlands in the dry years versus the wet years. Did I answer your question?
Do you use the NRCS soil maps to go back, like a dry year, even then the soil context is still there? You could go to the NRCS maps and still identify as the type of soil, and basically that would support a wetland even if it was a dry year. I mean, I haven't heard you mention those maps.
I actually have a really long presentation that kind of goes in detail of kind of our whole process, which I cut a lot of that stuff out for this. But there's a few other things that we use, as well as those photos. We use the soil maps. So we have a map, we have a digital map of the soils, and we identify everything that's hydric in those soils. So we can use that as another layer to, if we're having trouble figuring out if it's a wetland, we can throw on the hydric soils map, and if it's hydric soils, then we'll probably know it's a wetland there. We also use the USGS topo maps that have the nice contour lines. And so if we're looking at an area that looks kind of wet, but then we can see all those contour lines, so it's on a slope, probably not a wetland because it's on a slope. It's not a flat area. So those are the other two major data sets we use, as well as the photos, in order to identify those wetlands when we're going through this process. Process. So basically, the New England Fish and Wildlife Service has a master geo database. They call it a master database of all the wetlands, which right now contains the 1980s data set for Illinois. We basically got a dump of that database. So when they gave us all their data, so we have a database in our office, basically a computer database of all the wetlands. Each of those 6 interns, basically, they check out a county. They do the update process for that county. It goes through a quality assurance and quality control process to make sure that everything is right.